technologies that can destroy us. The technologies that can save us. It's Armageddon or salvation. From a nuclear nightmare to a nanobot invasion. From global warming to clean, endless energy. Now, Doomsday Tech on Modern Marvels.
The year 2019. Tensions between the US and Russia are running high. Russia's deteriorating early warning satellites mistake a US research rocket for an incoming missile. A panicked Russian command orders a massive strike. Dozens of missiles are launched at New York and Washington alone. With the Soviet attack confirmed, the US decides to retaliate in kind.
Launch key. Keys. On my mark. 3, 2, 1, mark. I got missile away.
All told, 7,000 warheads hit their targets in North America, Russia, and Western Europe, killing 189 million people in a half hour. The entire northern half of the planet is rendered uninhabitable.
The view from up here is always a beautiful reminder of how fragile and rare life is in the universe. And the fact that we can even enjoy this vantage point is testament to something else. To the stunning level of technological progress human beings have achieved in a very short time. There's a dark side to this story of progress, for we've reached a pivotal moment in human history when we as a species possess technologies that could destroy us.
We've always lived in a dangerous world, but the dangers until now have been more dangers from nature. Floods, pestilence, earthquakes, epidemics, etc. What has changed is that for the first time, the dangers confronting the world can be of our own making. We are changing the global environment as human beings, and our technology is possibly running away to the extent that it can destroy our civilization if mishandled.
For 60 years, the ultimate doomsday technology has been and remains nuclear weapons.
Mr. Gorbachev, tear down this wall.
Despite the end of the Cold War more than a decade ago, the US and Russia together have some 20,000 warheads ready to destroy each other's cities, many still on hair-trigger alert.
They're armed, they're targeted, they're fueled. They will fly out of their silo as soon as they get 2 very short computer signals.
Launch key inserted. Insert launch key.
The magnitude of this threat stems from one unchanging reality. The tremendous destructive power of a nuclear bomb.
When a nuclear weapon explodes, it releases unimaginable amounts of energy, literally in a few tens of nanoseconds. That energy is largely radiation, and it couples to the air and materials around it and drives a blast wave like a big piston, and that blast wave propagates out. In front of that blast wave, there are radiations, heat radiations, which will, for instance, set buildings afire, set people afire. And then very rapidly, the blast wave will come by and put those fires out, but will crush everything in their path, literally to dust. By the time the mushroom cloud is formed, everything's been destroyed.
If the birth of doomsday technology can be traced to a single moment, it would be a clear summer morning, August 6th, 1945, for the city of Hiroshima. And Nagasaki 3 days later, it was indeed doomsday. The bombs dropped over Japan were the only nuclear weapons to be used against humankind. Both bombs were fission devices. The chain reaction at the core of a fission bomb is the splitting apart of the highly unstable elements uranium-235 or plutonium-239, though many times more powerful than any weapon previously devised. The fission bomb was eclipsed a mere 6 years later by a weapon hundreds of times more powerful: the fusion, or hydrogen bomb. A hydrogen bomb, also called a thermonuclear bomb, uses a primary fission explosion to trigger a secondary fusion explosion. In the fusion explosion, deuterium and tritium, unstable forms of hydrogen, are fused, turning into helium and giving off extra neutrons in a chain reaction. Since the Cold War began, the Bulletin of the Atomic Scientists has marked our movements toward or away from nuclear annihilation by moving the hands of the so-called Doomsday clock closer or farther away from midnight. We were only 3 minutes away from midnight in 1953, after the successful US and Soviet H-bomb tests. With the invention of the hydrogen bomb, the evolution of nuclear lethality increased rapidly, and with dizzying variety.
We would have nuclear weapons on bombers that were on airborne alert, circling the globe 24 hours a day. And when you couple that with the posture that we and then the Russians adopted of launch on warning, where you wouldn't necessarily wait for a nuclear attack to occur, but you would launch on the warning of such an attack because you couldn't afford to be wrong, that just dramatically increased the dangers that we faced.
The introduction of the Intercontinental Ballistic Missile, or ICBM, was a watershed moment. An ICBM is a rocket 30 to 100 feet tall, filled with liquid or solid fuel. Once it's blasted into space, it can fly at 20 times the speed of sound. An inertial, radio, or satellite guidance system leads it toward the target, and the re-entry vehicle simply plummets to Earth. After ICBMs came supersonic nuclear bombers and submarines carrying up to 200 warheads, lurking off the enemy's coast and able to strike at cities in 5 to 7 minutes. Then came MIRVs, or multiple independently targetable re-entry vehicles. Missiles carrying up to 10 300-kiloton warheads, and small winged nuclear-armed cruise missiles that could be fired from ships or airplanes.
We had nuclear depth charges and nuclear air-to-air missiles and nuclear surface-to-air missiles and nuclear landmines, and anything you could put a nuclear bomb on, you did.
Between 1949 and 1990, the Soviets built 55,000 nuclear bombs. During roughly the same time, the United States built 70,000. With the end of the Cold War in 1991, the Doomsday clock moved back to 17 minutes to midnight. But in 2004, it read 7 minutes to midnight, exactly where it was in 1947 when the practice began. Russia's deteriorating early warning networks and the nature of its nuclear command are among the reasons for the heightened risk of doomsday.
Russia today has no effective, really early warning satellite network, which means that in conjunction with its decaying early warning ground-based radar network, there are large portions of the day, maybe upwards of 15 hours a day, where Russian generals have no idea whether they're under nuclear attack.
A frightening incident occurred in 1995 when a false reading by Russian early warning satellites caused then-President Boris Yeltsin to activate his nuclear football for the first time.
And so in January of 1995, a peaceful rocket launch out of Norway toward the North Pole triggered one of the most serious false alarms in Russian nuclear history, involving, for the first time to my knowledge ever, a president of either Russia or the United States in a nuclear decision-making emergency.
The greatest danger we face in the days, weeks, and months ahead is a nuclear 9/11. We hope and pray that it is not already too late to prevent.
Today, Russia is also struggling to guard its 1,000 tons of highly enriched uranium, or HEU, and 170 tons of plutonium. Enough fissile material to make tens of thousands of nuclear weapons.
The ranking member of the Senate Foreign Relations Committee has referred to the situation as sort of a nuclear Walmart. If you want to go there, if you want to get a nuclear weapon, that's the place to go.
There are 18 confirmed cases, mostly in the former Soviet Union, in which stolen HEU or plutonium has been seized by authorities.
Почему эту систему нельзя считать сейчас полностью надежной?
Why would it be a mistake to think that everything is safely protected? First, because the army itself that is protecting all this is more or less in a state of decay. It is destitute, and corruption in Russia is thriving. So it is impossible to rule out that the corrupt army elements could be selling weapons.
Meanwhile, every time another nation goes nuclear, the risk of nuclear war and nuclear terrorism spikes.
Just as the political situation changed several times in the 20th century, so it may in the 21st. And we have to be aware that 50 years from now, there could be a new geopolitical situation, a standoff between some new superpowers, which could lead to a situation at least as dangerous as the worst period of the Cold War.
The clock over my shoulder is ticking right now, and it's unfortunately, I think, just a matter of time before the weapons are used if we don't get them under control.
Nuclear weapons, like all technology, cannot be uninvented. But with great care, they can be maintained, dismantled, and guarded. Next, technology exists to tame the nuclear dragon and lower the chances of the unthinkable. In 2 years, 1959 and 1960, the U.S. built over 14,000 nuclear warheads, or about 28 warheads every workday. Doomsday tech will return on Modern Marvels. On the windswept plains of North Texas, inside a sprawling 2 million square foot complex, the deadliest devices ever designed by man are disassembled very, very carefully. This is Pantex, now the only Department of Energy site charged with the awesome responsibility of dismantling U.S. nuclear warheads. Pantex recently disassembled its 10,000th warhead.
Pantex is the place, the final assembly point or initial disassembly point for nuclear warheads in the United States.
The nuclear warheads arrive, moved from the nation's silos and bomb arsenals on heavily guarded trucks. In this rare footage, a B-61 nuclear bomb is separated into its sub-assemblies, including the radar nose cone and the tail section containing the parachute. Highly valuable electronic instruments are removed and reused if possible, and precious metals are salvaged. Pantex workers purposefully disfigure the classified components before disposing of them, so as not to reveal any secrets of the bomb. Then there is what nuclear weapons engineers call the physics package, the incredibly complex sub-assemblies that create a nuclear explosion. The primary, or fission assembly, is built around a hollow sphere of plutonium, called a pit. In the case of a hydrogen bomb, there is a secondary, or fusion assembly, built around highly enriched uranium, or HEU. Dismantling of the nuclear components takes place inside heavily reinforced concrete buildings, called gravel girties, built to minimize the effects of an unlikely nuclear blast. There are at least 12,000 plutonium pits stored at Pantex. The secondaries are taken intact to the DOE's Y-12 complex in Oak Ridge, Tennessee. In the U.S., some 58,000 nuclear weapons have been dismantled since the atomic age began. That's a lot of fissile material to monitor.
They control plutonium down to the level of a gram. They control uranium to the level of a gram. It makes Fort Knox look like Joe's Diner. We guard this stuff better than we guard gold. And it is accounted when it is moved from this place on a shelf to another place on a shelf. That motion is recorded.
The U.S. is also working to perfect the integrity of the nuclear weapons in its arsenal. This giant gas gun at Lawrence Livermore National Lab blasts a tiny projectile into a sample of the so-called insensitive high explosive. This is the non-nuclear explosive placed around the pit in a nuclear weapon. The weapon casing is enclosed in a steel chamber to contain flying shrapnel should it break apart on impact. When the gas gun is activated, the projectile is fired into the insensitive explosive at 18,000 miles per hour. This test helps the lab to design material so insensitive that it cannot be detonated by anyone or anything, except by this, the MSAD, or Mechanical Safing and Arming Device.
And in order to get it into line with the gun barrel so that it can set the nuclear weapon off, you require a very complex series of digits, zeros and ones, a code, which are mechanical. And if you don't put in exactly the right series of digits, it locks permanently. And I just locked it up by putting the wrong first digit in. And then the weapon is disabled. You can't set it off.
The U.S. Departments of Energy and Defense are also providing much-needed technical help to modernize surveillance and security at Russian nuclear sites. But the main tool in this endeavor is cash. The DOE is buying large amounts of weapons uranium from our former Cold War adversary and blending it into reactor fuel for U.S. nuclear plants. Ironically, the engine of American capitalism is running partly on fuel from weapons designed to destroy it. But the post-Cold War downsizing of the Soviets' gigantic nuclear weapons program left behind another expensive problem.
Over 5 million people were working on research, development, and production there, including over 540,000 with scientific degrees. I was one of them. 3 out of 4 scientists worked for the defense industry.
Many of them worked in closed cities, large walled-off secret cities that built the bulk of the Soviet nuclear arsenal. In exchange for their labors and their heavily policed lives, scientists and workers in the closed cities enjoyed a standard of living much higher than that of the average Soviet citizen.
They could buy themselves refrigerators, cars, and even have separate apartments for the family, which was a rare thing in those days.
So the main challenge today is to provide good jobs and salaries for these talented scientists and engineers, to ensure they're not tempted to sell one of the most important elements of a nuclear weapon: knowledge.
One only hopes that the closed cities problem will be solved without brain drain, that they will preserve what is in place there, and that they will become civilized scientific centers.
If a nuclear weapon does fall into the wrong hands, the next line of defense for preventing a nuclear 9/11 is detection technology.
This laboratory, for instance, is deployed radiation detection equipment specifically aimed at detecting materials in a nuclear weapon assembly. These sort of portal monitors, door monitors, if you will, are deployed across ports in the United States and our national boundaries.
Other scientists feel the best way to rein in loose nuclear material is to speed up the process of dismantling all the world's arsenals.
The way that we're going to get the Russian numbers down is to get U.S. numbers down in cooperation with Russia, to change the incentives for countries to go nuclear and to reduce the number of nuclear powers in the world.
Dismantling these doomsday devices forever is the dream of anyone who values life on Earth. And it will require more than technology to leave behind the age of nuclear weapons. It will require an unprecedented level of international cooperation. But even if we manage to defuse the nuclear threat, there are other technologies we use every day that could threaten our way of life. It's estimated that 750,000 Russians, many of them scientists, still live in closed cities. Doomsday Tech will return on Modern Marvels.
Welcome to the year 2034. 20-year droughts from the western U.S. to Asia's Mekong Delta have threatened world food supplies. Year after year of hurricanes have destroyed the economy of the southeastern U.S. and left New Orleans permanently underwater. Famine kills millions in northern Africa. Surging sea levels devastate Bangladesh. War is rampant as whole continents and a permanent refugee class fight over dwindling supplies of water and oil.
A grim scenario, but quite possible, given the nature and scope of one of the 21st century's most daunting problems: global warming.
If you measure human accomplishments to date in terms of sheer impact, you'd have to say, regretfully, that global warming may turn out to be the greatest single accomplishment of the human race, because in less than 1 century, we human beings, with our technology and with fossil fuels and oil, have actually affected the very chemistry of a planet in the universe.
Increased greenhouse gases result from a number of sources, including deforestation, and methane released by agriculture. But a growing majority of scientists trace the main source directly to our current hydrocarbon-based energy technology. Based on evidence ranging from tree ring analysis to ice core samples, which give temperature and atmospheric carbon readings as far back as 400,000 years, 2 facts are clear. The Earth's temperatures are rising at the quickest rate in 15,000 years. And there's more carbon dioxide in our atmosphere than there has been in 45 million years. Most scientists consider the connection between excess carbon and global warming to be beyond debate.
More and more scientists are coming to the conclusion that not only have we increased the greenhouse gases beyond any natural level, but we are now seeing that reflected in increasing temperatures.
Greenhouse gases trap the heat that radiates back from the Earth. This insulating layer provides the warmth for life on Earth. Today, excess greenhouse gases are overheating the planet. The near consensus has reached some surprising places, including some oil companies.
Excess carbon in the atmosphere, which is leading to global warming, is coming from a lot of sources. Principally human activity, and that's from the burning of fossil fuels, the use of coal and gas and oil.
Oil, coal, natural gas. They form the cornerstone of the modern world. Fossil fuels have been prized for their abundance, ease of extraction, and their ability to generate heat.
The basic process is converting the carbon and hydrogen of these materials into CO2, water, and heat. So you release carbon into the air in the process of releasing its energy.
Arguably, no other technology has changed the world so quickly and so completely. It's this incredible rate of change that may also make fossil fuels a doomsday technology. A world ravaged by drought, floods, and hurricanes. Potential global warming scenarios that the Pentagon now analyzes as genuine threats.
They asked us to look at a scenario of abrupt climate change and see what the consequences might be for U.S. national security. What I'm already discovering is that people are beginning to read it quite widely in the Pentagon and beginning to take it seriously.
Analysis of past climate shifts suggests a very different kind of doomsday scenario.
It is the year 2043. Much of northern Europe is locked in ice. Year after year of bitter winters devastate crops and animal species across the northern hemisphere. It is in fact the beginning of a new ice age that will last for hundreds of years.
How can global warming lead to sudden drastic cooling? Through a disruption of the ocean's thermohaline cycle, the intricate conveyor belt of salt water that circles the globe. One loop of this conveyor, the Gulf Stream, brings the equator's warm water and climate north, making Europe much warmer than Siberia, which is at the same latitude. constant evaporation makes the surface water saltier and denser as it journeys north, until it plunges straight down in the seas off Iceland and doubles back toward the equator. But the current melting of polar ice could disrupt this cycle by diluting the Gulf Stream with fresh water. If it became too light for its northern plunge, the Gulf Stream could stop, and Europe would enter a new ice age, quickly.
We've seen since roughly 1980 rapid warming of the atmosphere. We've also seen rapid melting and freshening of the North Atlantic. So all the signals are that we're getting precisely the conditions that would lead to the collapse of the Gulf Stream and an end of that flow of warm water toward Europe. And what it would mean is that Europe will begin to look like Canada.
Beyond global warming, and even a new ice age, there is a third doomsday scenario that may be brought on by our fossil fuels habit. The beginning of the end of oil.
The truth is that sometime in the next half century, we're going to start to run out of oil. The pessimists say 15 years, the optimists say 40 years. So that's the range. It's not 500 years, it's a couple of decades.
Are we going to peak in 2010 to 2020, as the pessimists say, or will we peak in oil production between 2030 and 2040, as the optimists say? And it hit me one day. It doesn't make a hell of a big difference. They're only arguing about 20 years.
It will be many decades, perhaps a century, before the world actually runs out of oil. But cheap oil will get harder to come by much sooner, as we approach what oil geologists call peak production, when half of the world's recoverable oil has been extracted. At that point, the theory goes, the price of oil will explode as awareness of scarcity kicks in. The magnitude of this comes from the simple fact that the modern world is not just utterly dependent on oil. It's dependent on cheap oil, and lots of it.
When anthropologists look back at this period in history, they'll call it the oil age, because the whole world revolves around the use of oil. It's not just the gasoline we put in the automobile for transport. Our food is grown in petrochemical fertilizers. Many of our pharmaceutical products are petrochemical based. Our packaging material, our plastics, it's all petrochemical. Transport, power, heat, light. We really do rely on oil for every aspect of our life.
The mid-20th century's green revolution in agriculture, which dramatically increased crop yields worldwide, was largely made possible by two breakthrough technologies: mechanization and petrochemical fertilizers. Both depend on cheap oil. Today, food for many of the world's 6 billion people depends on this equation.
The year 2019. The price of oil, $425 a barrel. A global depression sets in. Huge parts of the developing world stagger from the 1-2 punch of financial collapse and global warming-related natural disasters.
The countries that simply can't afford an energy source at that price will become much more disadvantaged. So there will be a separation between the haves and the have-nots to an extent that is even greater than it is now. The result of that is conflict.
Today, the oil economy is already submitting to the law of diminishing returns.
The United States government now spends more money maintaining a military presence in the Persian Gulf than the net value of the oil it's getting from the Persian Gulf, and that was before the war. That was $200 billion ago.
If the end of the oil age means a potential doomsday, it also represents an historic moment for energy technology. Advances in renewable energy may point the way to a brighter future. Between 1997 and 2004, China's crude oil imports grew by 225%. China has become the second largest consumer of oil after the U.S. Doomsday Tech will return on Modern Marvels. Fossil fuels, in addition to heating the planet, share one major long-term problem. They are finite. Even our vast coal reserves will run out within several generations. So energy experts are increasingly looking from the finite to the infinite. Some are going right to the source. Solar, or photovoltaic energy, is made useful by converting light, photons, into an electric or voltaic current. Silicon, a semiconducting material, is the principal component of a PV cell. As light strikes the silicon, electrons are freed. Minute traces of phosphorus and boron are added to the silicon. The different atomic structures of these elements allow a flow of electrons that forms the electric current, which is drawn away by a metal contact. The cells are given an anti-reflective coating to maximize absorption of light.
Where there's so much technology development so quickly that you reach a critical point where you're getting a doubling of information and a halving of costs every 18 months. That's happening with wind, it's happening now with solar and other renewables.
A quantum leap of sorts took place recently with the aid of nanoengineering. A California company called Nano Solar literally prints out paper-thin, micro-engineered sheets of photovoltaic cells that are far cheaper and more efficient than cells several times heavier. Invisible and omnipresent, the wind is another infinite resource, and the world is discovering its potential.
If you looked at the U.S. as an entity, from the Dakotas down to Texas, there's enough wind power to power the whole U.S. grid today.
There's enough energy in the wind worldwide over land in locations where the wind is sufficiently fast to produce all the energy, not only the electricity, but all the energy worldwide, 10 times over.
Wind power is a hot technology, and not simply because it emits zero carbon dioxide. It's also currently the most cost-feasible of the renewables. In fact, wind power's price, 3 to 4 cents per kilowatt hour, has become comparable to that of a new coal or natural gas plant. One key to wind power is a location with high wind speeds, mountaintops, plains, and offshore. But at the heart of this high-tech dynamo is a deceptively simple design.
The swept area, or the diameter of the blades, really determines how much power the wind turbine extracts from the air. Those today are large composite structures, fiberglass, similar to a large boat, if you will, boat building technology. That's what captures the wind. The parts of that also are fairly complex in that each blade not only rotates around but pitches in and out of the wind, so you can manage some of the stresses with wind gusts and different types, low wind conditions, high wind conditions, and optimize the stresses on your drivetrain.
The tremendous potential of wind power has certainly not escaped the attention of General Electric. Here off the coast of Ireland, it is partnered with an Irish company called Airtricity to build a wind farm composed of new giant megaturbines. From the base of the tubular steel tower to the tip of the blade, the turbines stand taller than a 30-story building. They must be pounded into the ocean floor with a hydraulic hammer.
The turbines that we see behind us are 3.6 megawatts, which means that they're capable of supplying electricity to about 3,000 homes.
Already Denmark gets close to 25% of its electricity from wind power, with Spain and Germany close behind. By 2050, Europe hopes to get fully half of its power from the wind. There are other bold technologies that will help reduce our dependence on fossil fuels, including more efficient hybrid cars, tidal power, geothermal power. Generating electricity without hydrocarbons will be a mammoth task. Storing that energy for a reliable power grid and using it to power millions of vehicles presents even bigger challenges.
Well, there is a way. It's called hydrogen. Hydrogen is the basic element of the universe. It's the stuff of the stars. It's the lightest element in existence. It's ubiquitous. And when you burn hydrogen, you only get two byproducts, pure water and heat.
You can also burn a lot of rubber, as evidenced by the BMW H2R car, fueled entirely by hydrogen. It raised eyebrows in 2004 after reaching a speed of 188 miles per hour. And contrary to popular myth, hydrogen fuel tanks are not a Hindenburg waiting to happen. Crash tests have shown H2 fuel tanks to be as safe as gasoline. But hydrogen, like electricity, is an energy conveyor, not an energy source. Extracting it requires significant energy and expense. The clean method of extracting hydrogen uses electrolysis.
You do the same thing that you would do in high school chemistry lab. You run electricity through water, and out of that comes oxygen and hydrogen. Very simple. It's the only byproduct. You let the oxygen go, you capture the hydrogen, and that's your fuel.
Hydrogen can be stored as a liquid, gas, or solid. And it can be used to produce electricity in fuel cells. It thus has the potential to replace gasoline with a clean-burning fuel. And to replace our energy grid, which cannot store electricity, with mobile decentralized power sources. Hydrogen economy or not, the combined doomsday potential of global warming and the end of cheap oil will likely reinvigorate a reliable but controversial energy source, nuclear fission power.
My view is that we will see a wholesale shift in the public attitude toward nuclear power because the alternative is coal. And so what we will see is a dramatic increase in the number of nuclear power plants around the world.
Scientists continue to chase the dream of nuclear fusion, both hot and cold. If it can be made practical, fusion could be a limitless clean source of energy that very well may save us. Just one of the many ironies of the ultimate doomsday technology, the atom. Cold fusion, once largely discredited, has gained renewed interest. In these cold fusion experiments at SRI International, a low-energy laser irradiates a rod of palladium immersed in an electrolyte of deuterium heavy water. The reaction generates helium, releasing 30 times the amount of the energy put in. In other words, evidence of a net energy gain, fusion at room temperature.
Most powerful reason to look at fusion of any sort is that the deuterium, which is the fuel for fusion processes, can be obtained from seawater. There is in fact enough deuterium in every gallon of seawater so that if converted to energy by a fusion process, a gallon of seawater in its natural state has 30 times the energy density of a gallon of gasoline.
Whatever path we take, replacing our current energy regime will be one of the biggest jobs we've undertaken as a civilization. In the 21st century, big jobs require small technology, like nanotechnology. But as nanotech converges with robotics, some say, beware the doomsday nanobots. The Earth's surface receives more energy from the sun in 1 hour than all of humanity uses in 1 year. Doomsday tech will return on Modern Marvels, here on the History Channel. Supercomputers, robots, cyborgs, androids. These intelligent machines, fictional or real, have long caused a vague uneasiness in the minds of the species who created them. A machine that turns against humans would be an especially cruel doomsday technology. Our fear of such a day may only increase as computers and robots become more human-like, and human beings more machine-like.
So we'll have very powerful non-biological systems that have the subtlety and suppleness and pattern recognition powers of human intelligence, combined with the ability to share knowledge instantly, to think much faster, much more accurately. But it's not just going to be a competitor, sort of an invasion of alien intelligence coming from over the horizon. It's emerging from within our civilization, and we're going to quite literally merge with this technology.
The age-old fear that machines may one day get the better of man has surfaced again, this time due to the cutting-edge field known as nanotechnology.
Nanotechnology is anything that is of nanometer scale. That's 10 to the minus 9 meters, or about 1,000th the size of a human hair.
Also called molecular manufacturing, or atom tech. Nanotechnology is essentially manufacturing with tiny bits of matter, even down to the atom. It can create new super-strong materials and even tiny machines that will build more tiny machines on nano-assembly lines. The positive applications of nanotech are virtually limitless. The recent introduction of nano-nickel may cut the cost of automotive fuel cells by 75%. New devices detect chemical warfare agents using parts assembled on the molecular level. Nanomedicine is especially intriguing.
In the near term, there's some very exciting work taking a nanoparticle, coating half of it with gold, putting a functional molecule on the other end, sending it into a biological system, such that this molecule here binds to a cancer. I believe in my lifetime, very small nanosystems will be injected by a surgeon into the body to actually do repair of tissues, cells, and molecules in the body.
Any technology this powerful and this tiny must have a potential downside. And even nanotech proponents warn of potential abuses. The main fear has to do with the future of nanomachines, or nanobots. Specifically, self-replicating nanobots.
Self-replication will be needed constructively in order to scale up nanobots to a useful level, because one nanobot doesn't do anything. You need trillions of them, so at some level there has to be self-replication to get up to those numbers.
Critics ranging from Sun Microsystems founder Bill Joy to the Prince of Wales warn of a terrifying doomsday scenario.
The year 2046. In a common practice, billions of nanobots designed to consume hydrocarbons are released to absorb an oil spill off the coast of Louisiana. But the nanobots, through a programming error, begin devouring all carbon-based life forms around them. As they self-replicate exponentially, they replace all matter with copies of themselves. Within days, the world is turned to dust.
This scenario has been termed gray goo.
It's the exact same specter we see in biology, where you have viruses or bacteria or cancer cells just replicate. Cancer cells start replicating, and then they take over our bodies and turn all of our good cells into copies of themselves. And so uncontrolled self-replication is a great danger.
This is, at the moment, still science fiction, and many of us think it will remain so. But, of course, we have to bear in mind that many things that seemed science fiction 100 years ago have become stark reality by now. And so the possibility that nanomachines may have unintended consequences is something which all those involved in that technology should be mindful of, in my opinion.
This may be especially relevant if nanotechnology continues to merge with the human mind and body, which many experts in the field would like to promote.
We're ultimately going to have a world where we're going to have billions, in fact trillions, of nanobots. They'll be in our bodies keeping us healthy, they'll be in our environment keeping the environment healthy, and they're going to be running software, and it's really going to be a means of who controls that software.
One thing is clear. In the 21st century, small will be big. Computer science, biology, genetics, and robotics are all beginning to converge on the nano level. It will take considerable effort to ensure that small technology doesn't become a big problem.
I do believe that this is going to be the next industrial revolution. This is going to be a very, very big change for our species in terms of what we will be able to do, both positively and potentially causing some problems.
As with all technology, the cutting edge cuts both ways. The energy source that created the modern world may endanger our civilization. The deadliest weapon ever devised may point the way to a limitless source of energy. And the most exciting future technologies are also the least predictable.
What we're seeing in this century is new technologies which produce greater risks and greater opportunities. And we have to ensure that we can harness the opportunities and avoid the risks of misuse. And these risks are great because even a single person is acquiring the amount of power which was the prerogative of a nation state 50 years ago.
We've managed to avoid doomsday so far. But the fact that we actually have the power to bring about our demise should give us pause. In our endless quest for knowledge, we will also need the wisdom to remember the big picture.
His army defeated legions of warriors, then marched to the very gates of